Newton's Law of Motion Part 2. By the end of this topic, you will be able to describe Newton's second law of motion. Describe Newton's third law of motion. During a game of table tennis, if the ball hits a player, it does not hurt the player. However, if a fast-moving cricket ball hits the spectator, it may hurt him. A bullet with small mass can kill a person when fired from a gun. However, a moving truck, even at low speed of 6 meters per second, may kill a person standing in its path. From these observations, we understand that the impact produced by the objects depends on their mass and velocity. Also, momentum is equal to mass into velocity, that is, P is equal to mv. Newton's second law states that the rate of change of momentum of a body per unit time is proportional to the applied unbalanced force in the direction of force. F is equal to dp by dt, where dp is change in momentum and dt is time taken for change in momentum. Mathematical formulation of Newton's second law. Let us consider a body of mass m moving with initial velocity u. If a force F acts on the body for time t, then the velocity of the body after time t is v. Initial momentum of the body Pi is equal to mu. Final momentum of the body Pf is equal to mv. Now, change in momentum of the body is equal to Pf minus Pi is equal to mv minus mu is equal to m into v minus u. Time taken to change this momentum is equal to t minus 0 is equal to t. Rate of change of momentum is equal to change of momentum by time taken, which is equal to m into v minus u by t. According to Newton's second law of motion, force applied is directly proportional to rate of change of momentum. F is directly proportional to m into v minus u by t. Since v is equal to u plus at, or v minus u by t is equal to a, therefore equation 1 can be written as F is directly proportional to ma, or m is equal to kma, where k is constant of proportionality. If F, m and a is equal to 1 unit, then in equation 2, F is equal to ma. Thus, force acting on the body is directly proportional to its mass and its acceleration. Impulse of force. In certain cases, measuring time is very difficult for calculating the momentum. For example, when a hammer strikes a nail, it is very difficult to measure in how much time the hammer came to rest. The force on a body which acts for small duration of time but produces a significant change in its momentum is called impulse of force. Impulse of force is equal to force into short interval of time is equal to change in momentum, which is equal to F into t equal to m into v minus u. The effect of impulse of force is measured in terms of the change in momentum. Applications of Newton's second law of motion. A cricket player lowers his hands while catching the ball. This is because when a player lowers his hands, the time to stop the ball is increased and hence less force has to be applied to change the momentum of the ball. Thus, the hands of the player are not injured. A person falling on a cemented floor gets injured, but a person falling on a heap of sand is not injured. When a person falls on the cemented floor, the rate of change of momentum is very large as the person is abruptly stopped. Hence, the person gets injured. On the other hand, when a person falls on a heap of sand, it yields under the weight of the person. As a result, the person comes to rest in longer period of time and he does not get injured. Example 1. A bus of mass 5000 kg starts from rest and rolls down a hill. If it travels a distance of 200 meters in 10 seconds, let us calculate acceleration of the bus and force acting on the bus. Solution. Here, mass m is equal to 5000 kgs. Initial velocity u is equal to 0. Displacement s is equal to 200 meters. Time t is equal to 10 seconds. We need to calculate acceleration a and force F. Using S is equal to ut plus half at square, we get 200 meters is equal to 0 plus half a into 100 second square, or a is equal to 4 meter per second square. Using F is equal to ma, we get F is equal to 5000 kg into 4 meter per second square is equal to 20,000 kg meter per second squared is equal to 20,000 Newton. Hence, the acceleration of the bus is 4 meter per second squared and force acting on the bus is 20,000 Newton. Example 2. A car of mass 1200 kg is moving with a velocity of 90 km per hour. When brakes are applied, its velocity reduces to 36 km per hour. Let us find the change in momentum. Solution. Here, mass of the car m is equal to 1200 kg. Initial velocity of the car is equal to 90 km per hour, which is equal to 90 into 1000 by 60 into 60 meter per second, which is equal to 25 meter per second. Final velocity v is equal to 36 kilometers per hour is equal to 36 into 1000 by 60 into 60 meter per second is equal to 10 meters per second. Initial momentum of the car is equal to mu is equal to 1200 into 25 kilogram meter per second is equal to 30,000 kilogram meter per second. Final momentum of the car is equal to mv is equal to 1200 into 10 kilogram meter per second is equal to 12,000 kilogram meter per second. Change in momentum of the car is equal to 30,000 minus 12,000 kilogram meter per second is equal to 18,000 kilogram meter per second. Hence, the change in momentum of the car is 18,000 kilogram meter per second. Newton's third law of motion. A boat moves backward when a person jumps out of the boat. A gun moves backward when a bullet is fired from the gun. A rocket moves forward when it expels hot gases with high speed in the opposite direction. Newton's third law of motion answers these questions. It states that whenever one object exerts a force on the second object also exerts an equal and opposite force on the first. Therefore, when a boy jumps out of the boat, pushing the boat in backward direction, the boat exerts an equal and opposite force on the boy. This helps the boy moving in the forward direction. When a bullet is fired from a gun, a force is exerted on the bullet and the bullet accelerates in the forward direction. An equal and opposite force is exerted on the gun, due to which the gun moves in the backward direction. The same principle is used in rockets too. The rocket expels hot gases with high speed in the opposite direction through a nozzle in the rear end. An equal and opposite force pushes the rocket in the upward direction. Force can interact without contact. Interaction between two bodies can also take place when they are not in contact. For example, a magnet can attract iron pieces or deflect a compass needle from a distance. A comb rubbed in dry hair can attract pieces from a distance. Our earth is round because of gravitational force. Summary. Let us summarize what we learnt in this topic. Newton's second law states that the rate of change of momentum of a body per unit time is proportional to the applied unbalanced force in the direction of force. The force acting on the body is directly proportional to its mass and its acceleration. The force on a body which acts for small duration of time but produces a significant change in its momentum is called impulse of force. The effect of impulse of force is measured in terms of the change in momentum. Newton's third law states that whenever one object exerts a force on the second object also exerts an equal and opposite force on the first. Interaction of force between two bodies can also take place when they are not in contact.